Good morning, everyone. Welcome to another technical webinar of this first open call by SPADE. Today, we'll be presenting universal considerations across use cases, a topic that involves two challenges you can apply to. Sorry, I have a problem with my slide. Okay, so to provide us with more details on these challenges, we have Emad Samuel from SPADE EU. Following that, we will have Pablo from Gradient to give you details about the SPADE platform. And finally, Philippe from Eclipse Foundation will provide open source recommendation for this open call. And remember that at the end of all presentations, we will have 15 minutes to answer participant questions. To provide us with more details on this challenge, to ask your questions, we have the question and answer function in Teams, as can you see in my screen. You can find this button at the top of Teams with a question mark icon. And when you click that button, this panel appears, and that way you can write your question, and we will be more than happy to answer them, okay? So after these clarifications, I will give the floor to Emad from SPADE EU. Emad, can you hear me?
Yes, I can hear you. Thank you,
Okay,
Maria.
great.
Okay, I will share my slides and then we take it from there. Okay. Okay, hope you can see my slides.
Yes, we can see it. Great, Emad.
Okay.
Sorry, Emad, now we cannot see it. Now we can see it. Wait. So, yes, it's working.
Yeah, so we speak about the drone hardware software architecture for the use cases, what kind of sensors and onboard computers, and how the drone swarm look like, and the internal parts, and the drone manual that one could read. So how we see the overall system. So I'm just trying to see if I can get the pointer. Yeah. So we see the system to start from an airframe, which is a classic carbon fiber frame with ESCs, motors, and propellers. And this is kind of a reconfigurable airframe, so one could change the motors to make them lighter or heavier to lift the right payload. And this airframe will have on board a low-level flight controller. And here we use the PixHawk project with PX4 as an autopilot, which is also open source, so one could also read how this is working. And by combining the autopilot with the frame, so we can have a drone that can fly based on commands coming from a remote control. So we can manually control this drone to go up and down. And that is something, yeah, one could find easily online on how this hardware software work to configure the low-level flight controller and to steer the drone. The new part that we are building it here, or also giving it for the drone platform, is the autonomy. How to make the system working by itself, so you don't need a ground operator. And that is very important for the swarm, especially to say where the swarm should go, how they can collaborate, and so on. So that will come through the onboard computer. It's like a high-level controller sending commands to the low-level controller to tell the drone where it should go. And here we can see many different types of hardware. One could be a Raspberry Pi, so a CPU-based running ROS2. ROS2 is like a middleware, allows you to communicate between sensors, actuators, or other nodes, and also sending commands to the low-level flight controllers. From our side, we will deliver to you a running ROS2 nodes on the hardware that one could say disarm the drone, go up, go down. So, you know, some basic functionalities to control the drone using ROS2. So it's imagine a computer is controlling the drone. Yeah, and if one needs extra functionalities or more fast processing, so we have also other two options. we can have an NVIDIA Jetson Nano on board that is also running ROS in the CPU, and you have a GPU to accelerate maybe an AI algorithm or a heavy task. Or you have the same CPU running ROS2 and an FPGA to accelerate a heavy task. So in this way, you have the CPU free only for ROS to communicate with the low-level flight controller and the sensors, and the heavy calculation going to the FPGA. So it's like a S3 hardware. They are easily swapped because of ROS makes it quite generic enough to communicate with the low-level controller. Sensors speaking, the drone will have its own small RGB camera connected with the Raspberry Pi. Yeah, and it depends on the case. One maybe needs a stereo camera to estimate the distance and so on. So yeah, so that we need to discuss. Yeah, how heavy is the camera and so on. But for now, the drone can carry a small stereo camera, like inter-real sense, and then yeah, the camera somehow has to be a part of the algorithm, maybe for the swarm. Then a lot of work coming in the CPU side. How to communicate between drones? So imagine this is one full drone. I'm just making this with a pen. So that is one full set of drones. So imagine another copy, another drone, and we only see it from ROS, running another ROS node, communicating with the computer here, maybe through Wi-Fi connection. And then here, the coordination between the drones should come as a coordination between different ROS nodes. And the same coming towards the cloud. So if the data has to be observed through a cloud server or a service running in the cloud, so that will be a communication between the onboard computer and the cloud. Okay. We have a publication here. One could read about how this open framework for ROS2, BX4, and the FPGA work, and the paper in the bottom to get a sense of how this architecture works. Yeah. And this is a prototype of the drones. You can see it's a small size drone, can basically can run different tasks in the FPGA and the CPU side, and also it has a camera, and also we use here some lightweight millimeter wave radar to estimate the distance. Maybe it could be also useful for the swarm work. It depends, of course, how the swarm is designed. A little bit about the onboard computers, and here it depends on the skills, and I will share with you my knowledge. If I speak about a Raspberry Pi, so I speak about a short development time. Let's say maybe a couple of days, you can get it up and running in a Raspberry Pi. Performance speaking is quite low. Performance here I speak about if it's a swarm, has to go right and left, maybe it will not be that efficient because of the delays in the hardware. But if you spend more time and make some good optimization, then you can basically make it better performing CPU work. So instead of 2-3 days, it became maybe 1-2 weeks. Or we're starting by GPUs, a little bit extra time to configure a GPU, and the performance will be a little bit lower than a CPU. Or doing optimization, and here we speak about weeks. Or if one wants really the high performing real-time operating work, then the work will come between CPUs and FPGAs. And then here you spend more time, but you will be the most performing setup that you will have. Yeah. If you know a little bit about FPGAs, they are quite efficient, but also needs time to tune everything. So it depends on the task. One could select, shall I go CPU, GPU, and FPGA? That is what the drone design will have. It will have the SPADE enclosure in the bottom that carries the different hardware. It is designed to kind of as a swap computer. You can put one of the 3 card-sized ports inside, and all will be flashed with a ROS2 to communicate with a low-level flight controller that is standing here. Yeah, and that is the explanation of the drone and what is inside, and it has the GPS receiver, telemetry, radio link, and that this radio link is for the transmitter. And at least in Denmark, is mandatory to have always, each drone has its own radio link, so you have always the upper hand to terminate the mission. So if I have a swarm of 4 drones, I would expect 4 ground operators, each one has a remote control to terminate the mission if something goes wrong. And usually use the telemetry radio link for knowing the status of the drone. And then you have the communication between the flight controller through the ground control station, sending data through the telemetry radio link. And then drone-to-drone communication through basically the communication from the onboard computer. As I said, it's Wi-Fi connection. Could be easily used, or maybe 4G or 5G if you have a kind of the right chip to connect here with a SIM card. It's a USB connection anyway. Yeah. Yeah. And the good thing also in this design, if something breaks, you can have a 3D model. You can 3D print the guards, for example, or the legs, or the case here. So you have a kind of more freedom to fix the drone after crashing, which is expected anyway. Yeah, and here is a test of the drone. It was carrying around 350 grams of payload, and you can see it is flying inside this room setup, and that is without any tuning. So that is a performance of the drone. When you fly outside, is flying quite smooth and without any mubbling. Yeah. To read about this, we are putting the manual and how to build the drone and fix and print and so on in Eclipse website. And for the moment, we are putting it our own local GitHub. When you click here, you will get to know the different component and how to construct the drone and flash it with ROS2 and get it to be up and running. That's it from my side. I don't know if there are any questions.
Thank you, Emad. The questions will be at the end of all the presentations, that we have 15 minutes for that. So thank you for your presentation. And now we will continue with Pablo.
Okay.
Like, we can see your screen.
Okay, thank you. So I'm Pablo Couñago. I'm a developer and researcher with Gradient, research center here in Spain. And I'm gonna talk about the SPADE core platform. We as Gradient, as participants in the SPADE project, have a role to define this core platform architecture and develop it during the project. So I'm gonna talk about what we have designed and what the role of this platform is in the SPADE project. So the SPADE project is composed of different use cases, different pilot projects that are based on the use of drones for some tasks, and they all generate a set of information that need to be treated differently. And our goal here in SPADE is to collect all this information, give it a semantic layer or a layer of structure and understanding to all that information, and have it available in the platform so that it can be used for many different applications. That's what we are gonna talk about in these open calls, which main goal is to use this information to perform some task and return a result using that information as a starting point. So our architecture is based on a central central entity, which is the SPADE core platform, whose where every pilot will connect to using this entity we call the data broker. The data broker is a service that is developed by our colleagues at Bavenir. We have Jorge here with us, who can answer any question you have about that. This data broker has two main goals. The first one is to collect information from the pilots, from specific platforms, databases, APIs, or whatever data source they have, and make it available in a secured channel to the cloud services we have in the SPADE core platform. The other role of this data broker is to provide a service discovery system. We're going to discuss it later because it's used in our service library part in the SPADE core platform. So we're going to talk about that later. And that's what we will use this data broker to share information, not only between the pilots and the SPADE core platform, but also between pilots themselves, which can maybe share functionalities that they use and is available in one pilot, but is maybe useful in others. So we have that possibility if it's needed. Well, in the architecture, we have that. The main entry point of data is the data broker. We have also a database inside the platform that we can use to store information about the platform performance, logs, errors, any other information that is generated inside the platform can be stored there. We have also some user interfaces that we can use to interact with the platform, and we have some security layer that we will use for access management of users, authorization and authentication of users, and the main point of the SPADE core platform is this what we call the SPADE marketplace. This marketplace has two main parts. The first one is the digital twin platform. I'm not gonna get into much detail in this part because that's not the main goal of the open calls to interact with this digital twin part, but I'm going to give a brief introduction of what we mean by digital twin platform. We are using the AAS Asset Administration Shell standard to develop a set of digital twin templates that we can use to represent real-world assets. We are first of all targeting at representing information generated by the drones that work on the different pilots, and we want to represent this the information generated by these pilots in the digital twins in our SPADE core platform. We have these templates available in a digital twin template catalog in the platform, and every user can use these templates to connect their pilot to the platform and have an instance of digital twin specific for their use case in an easy way and without the need to develop it from zero, from start. That's the digital twin part of the system, and we have the service library, which is what we are more interested in this webinar, which is useful for the use cases. The open calls will use this service library as a way to both communicate with the SPADE core platform. Is the main channel where they're gonna receive requests and receive input data from the system, and that's where they are gonna return the result of the calculations or whatever action they have to perform. This is the main communication channel that the the open calls services are gonna talk to the platform. The communication channel used for this communication is the data broker. The data broker acts as a communication channel where every solution developed in the open calls are gonna register to this data broker so that they are discoverable by the rest of the platform. Everyone can make a request to the data broker, and know what services are running on the platform, both inside the SPADE infrastructure or in an external infrastructure, maybe in the pilots or in other cloud services. This list of available services is going to be published in the service catalog that will also include a user interface where everyone can browse through the services, get access to API information, to input and output formats for those services, and so on. And we have in the SPADE core platform, we're gonna provide a runtime where we can deploy different service instances and have them running and controlled through the use of them, and through the receive of requests and so on. That's it from this, and I'm gonna give now a brief list of requirements we have agreed on. We are going to provide a runtime environment based on the Linux file system, on the Linux operating system. Sorry. We're going to provide a Docker-based runtime. Every solution developed by the open calls needs to be packed in a Docker image. And if more than one service is needed, we require a Docker compose description file so that all the services can be run together in an organized and coordinated way, so that we don't need to install separate dependencies and so on. Everything is well defined and well configured this way. Regarding hardware, we're going to provide only general purpose hardware. We're not providing GPUs or any other specific acceleration hardware. So if that's needed for a specific use case, we have to discuss it particularly and decide if it's possible or not. We're not gonna take that into account by default. And finally, all the solutions, of course, have to be well documented. We need the manual, the user manual, the installation instructions, the maintenance instructions, how to correct bugs or detect errors and their common solutions. And I think that's it from my part. As you all know, there will be a question time at the end of the webinar. So if there's any question, I will happily answer them with that period.
Thank you, Pablo. Now it's time to continue with Philippe. Philippe, welcome.
Thank you, María Elena. So I hope
Pablo, just give me a second. Pablo, can you stop to share your screen, because that way Philippe can share.
Yep, sorry.
Okay, great. Sorry, Philippe, go. Sorry.
No problem. I hope I will be able to share it. I will be better than this time than last time. So let me try that. And okay, enter screen. This one, share. Okay, good. Can you see my screen?
Yes, we can see it.
Good. Great.
Right,
So,
Philippe.
Oops. Thank you. Oh, I don't know what's going on. Okay, weird behavior here. Let's see if it's because of my mouse. And let's come back. Okay, I hope it feels better now. Okay, so my name is Philippe Krief. I'm Research Relations Director at the Eclipse Foundation. And then, I've been asked to present the open source recommendation for these case studies. As you saw already, that all the stack where SPADE is based on is open source. When we talk about ROS, when we talk about Linux and the rest of the platform, so it's important to pay attention on that. I mentioned here Eclipse Foundation just to remind you that maybe you heard about us, and certainly you heard about us a long time ago. It's more than 20 years. This year is the 20th anniversary of the foundation itself and the Eclipse IDE. We just for you to show that we are a strong foundation with supporting more than 400 open source projects, and we have most of our members are European. And it means that the results of SPADE will be hosted at the Eclipse Foundation under the Eclipse Foundation portfolio. So it will give you also a strong visibility in terms of your results. So I really encourage you to provide nice results and to be selected. And I wish you to be selected like that. You have this kind of wide visibility inside our community. SPADE has a common platform, and this common platform will be open source. So it's important. And just quick reminder about what we mean by open source and what kind of license will be applied. So if we start from a proprietary license, which is completely closed, to a non-commercial license where you can use the product, but you cannot make business with it, to what we name a strong copyleft license, which starts to be the open source license, where actually you can certainly share your code, but if you use any other GPL library, you have to be GPL as well. So it's a strong copyleft in this case. To after that, what we name it weak copyleft or permissive licenses, where actually you can use the library. On the case of weak copyleft, we ask you to give it back to the community if you identify an issue in the code that you are using. And then you decide to fix it. And a permissive license that nobody really cares, you can share back or not. What we decide with SPADE, for now, we didn't make any final decision between weak copyleft or permissive license, but by the beginning of the proper project, the open calls, we will decide which license will be used between Eclipse, Apache, BSD, or MIT. But it's one of the recommended license, and we ask you to select one of these licenses for your code as well, to make it business friendly for us and for yourself, as we do with our code. SPADE also will adopt an open collaboration approach. By open collaboration approach, we mean transparency. Transparency means that we will share with you our progress in terms of development plans, in terms of issues. So it means that if you have any concern, any issue, you will be more than welcome to write your issue on our shared GitLab repositories, and we'll provide an answer. And of course, if somebody already identifies this issue, you will take advantage of that because it will be totally transparent. Openness as well, so we accept everybody without any restriction, but specified in the open calls. And then after that, the other one, which are meritocracy that we apply at Eclipse, which means that you can participate if you contribute to a project. If you are not just here to watch that, it's different. You have a different role. And vendor neutrality also for us is very important. That we don't have we will not have any preference. We consider that the community selects the winner, not us. So it's part of our open source best practices, and we'll ask you to follow them. To support this open collaboration, we install SPADE on what we name an Eclipse Research Lab, name it the SPADE Research Labs, and it will host all the repositories of the SPADE project and also the repositories of the open calls. So we will ask you to develop under this infrastructure, and which is ultimate GitLab infrastructure, and we will ask you to develop from start, and not only to push your code when it's over. It's not very interesting, and you don't give us a chance also to if you are facing an issue, to exchange with our development team. It will be very difficult for them to understand or maybe to reproduce a problem when, if we have access to your code, it will be definitely easier. And you will take advantage as well by that that we will be able to scan your code and identify potential issue to protect you and protect the user of your code. Protect you by the fact that we will check that you mention all the copyrights because you wrote the code, so you own the code. So we will verify that you use correct copyrights, and also that you select a correct license. The third thing that we also verify during these steps are the dependencies, because you certainly might have some dependency with some other libraries, and we will verify that these libraries are really open source libraries, because if they are not open source libraries, then your code will not be a real open source. So we do all this IP review for you for free. So as I mentioned here, the benefits: issue directly supported, testing, and continuous integration. As well is very important, because you will have, as soon as the problem will be fixed on our side, you will be able to take advantage of the fix, and we'll support you on intellectual property and the third-party dependencies. The request on the other side, we'll ask you to create, if you don't already have one, free account on the Eclipse Foundation. So it's very easy, it's straightforward. And then after that, from your profile, but we will remind you all the steps when it will time to do that, to sign the Eclipse Contributor Agreement. This agreement, it's a usual developer certificate of origin, which guarantees the fact that you know that you are open sourcing your code. It's not that you are completely drunk when you did that, and that you and your organization also agree that you open source your code. And if you share the code which from somebody else, that the other one is also, they agree also with that, so everything is clear. All of us are on the safe side of the discussion and sharing things. And we'll ask you, of course, to select what we name industry-friendly open source license, and we will tell you which one we selected, but it will not impact. You will be able to select any of these 4 other licenses without any difficulties, knowing that all of them have a strong community and very popular in the world of software development. That's it. See if you have any question. So I will be here for the QA, or you can contact me directly if you wish later on for any more questions. Thank you very much.
Thank you, Philippe. So to our participants, now we will have 15 minutes for questions, and remember that you have question mark icon at the top of Steam, and there you can write your questions, okay? And we'll be more than happy to help you in this way to apply for the Fears of Open Call. I don't know in this time where we are waiting now for the question, but maybe in this time, I don't know if some of the or speakers want to add something else, maybe something that forgot or any point, I don't know.
I'm very impatient to see some cool examples.
Yes, I hope to receive a lot of application for this open call because I think that we have great topics to apply here. We have a great team also here to answer your doubts, guys. So please don't be shy. And this is the time to clarify any doubts. And remember that we have a frequently asked question document on the website, on the SPADE website, where you can find a question received through the support channels and also received through these technical webinars when we can clarify your doubts there. So maybe you wasn't possible for you be here in the other webinars, but there you can find other clarifications in that document, in the frequently asked question document in the SPADE website. And remember that also we have a support channel dedicated to clarify doubts. I will write the sorry, the email, and that way you can see it. Give me a second.
Maria Elena, in the meantime, I tried to access the Q&A session, and I was able to do it before we start, and now I cannot reach it anymore. So just saying, it says there is a problem reaching that.
No, I am checking here, and
Pablo, Emad, can you reach it? You're on mute, Pablo.
Yeah, I'm trying now.
Okay.
No, I think because it's only for the participants, not for you guys. Sorry. Yes, I was checking right now the configuration and everything is okay. It's working.
Okay, good.
And right now, for example, I publish the email and it's working too. I don't know. I suppose that you can see it. You cannot see it, no? The email published.
No.
No, because it's only for the participants. So
I can see it, Maria Elena. So
yes, because in this case, Aris,
and the Q&A works. I can verify that.
Yes, the problem or the speaker they has like another rights, and in this case, Aris is one of the participants, so he has the right to ask questions. But the speaker are here to answer them, so maybe all is clear because we don't have questions. I don't know, maybe in this meantime, maybe Emad, if you want to summarize something about this topic, something, quickly, like a summary for participants.
Yes, I mean, one always think about this, the drone system as a normal computer, seeing it from the top, as you see any Linux operating system. And something one could consider also to use simulation before building things in real hardware, especially for drones, because they can crash easily. But if you test them in simulation, then you know how they behave, how they can fly, and what kind of issues they have. They have a lot of also software issues, but from software side, you will get to be more confident before trying first time outside. Of course, you will be dealing with really difficult technologies and things can go wrong. So you need always to think when it is outside, maybe you need to connect the drone with a wire to the ground so you don't have it flying far away. So you be sure that it's coming back, or put them inside a cage to be sure that they are protected somehow. They cannot really go far away. And you always consider it is like a computer. Bugs will come. And imagine a bug in a drone, what that mean? Yeah, maybe the drone is flying by itself, will never come again, or no, it's not flying or crashing with each other. So you need always to think about how to protect from a certain types of situations, especially in the development phase. So we usually test using gazebo, connecting with PX4 and ROS2 in the software environment to be sure that the drone swarm or the drone itself is behaving as it should. And then after, it doesn't take too much time to put it in a real drone hardware platform. Yeah. So that would be my advice.
Thank you, Emad. Thank you. I share also the SPADE website and the way the participants can check all the open call documentation there. And remember, if you have any doubt, you can send an email to the email that I share on the question and answer section, okay? So I think that maybe all is clear for our participants. Sorry, we have a question. Okay, let me see. This person already applied for the SPADE project, but he forgot to mention these following challenges. So he forgot to mention what challenge he chose. Sorry, I will check your application because normally it's impossible to apply if you don't selection one of the challenges. So that you are, sorry, I can see it. So maybe the problem is this applicant, he choose the ground challenge because he want to apply for another one related to the use this topic. So don't worry, please send me an email and we will share your application and we will open your application again, and that way you can correct this mistake. Okay, it's not a problem. In the guideline for applicants, we mentioned this, that if some of the applicants need to change something in their application, it's not a problem. He need to send an email to the channel support and we will open the application again. But it's important to notice that this will be possible only during the timeline that we have for the open call. So we cannot open applications after the deadline, okay? This is really important. So, Emma, can you, if you can see it, we have a person here that already applied for these challenges. So that is a good news for us. So this is the only question that I received. Maybe we can wait 2 minutes more because maybe it takes time to write the question on the chat. Yes, Philippe.
Yeah, I thought that you ask Emad to summarize. I thought that you will ask Pablo.
Yes, of course. Sorry, Philippe. Well. Thank you for remembering.
I'm myself to a smart sentence.
Sorry, yes, you are right, Philippe. Sorry. So we will start with the same order that the presentation. So the first one was Emad. Now, Pablo, if you can summarize something regarding this open call. Thanks, Philippe.
Yeah. Well, the main idea with the open calls is to develop a service that is useful for our use cases, to develop a solution that gives an answer to one of these challenges. And we provide this platform where we can integrate set solutions, and they will be available for not only these use cases, but maybe for future ones. And that's it. We will be available to solve any question, to provide documentation and insights on what the APIs we use, what the architecture is, and any requirements we have. So yeah, we'll be available to solve any question.
Thank you, Pablo. Philippe, now it's your turn.
Okay, so I think this open call is very interesting because of this aspect of open collaboration. And usually when I talk about open collaboration, I said that stop inventing the wheel, invent the car. I should say here, stop inventing the propeller, invent the next generation of drones. So let's go for it and enjoy this kind of cool open calls.
Thank you, Philippe. I want to remember to our participant that you can only apply for one challenge, okay? You cannot apply for all the challenges that you want. I know that you have the experience, that you have the technical expertise for this, but you can apply only for one challenge, okay? This is really important. Okay. So we don't have more questions. Okay, guys, thank you a lot for your time. I am sure that I will receive more questions through email, so don't worry, because I will send your task, and the task will be, of course, answer these questions for our participants. And thank you a lot for your time and for being here today, and have a great day to everyone.
Bye-bye.
María Elena.
Bye.
Bye-bye.
Yeah, bye-bye.